In the video you just watched from me many years ago, you saw three major things and three major phrases that we took definitions of. The first one was isolate a variable. And I'm going to have us do all three of these steps every time we solve an algebra problem, even though these first couple problems seem like I don't need to. This is extra work. It seems like it's useless information because I can see it. I can know the answer. Promise these three steps will help us as we get progressively harder and harder through algebra, all through next year as you start to go through algebra, and then all the year after in your freshman year of algebra. If you can really solidify these steps as algebra gets progressively harder and harder and harder, these three steps will really, really help you solve. So those three steps are isolate like a variable, step number one. We'll get to steps 2 and 3 as we go through this one. But three major reasons we isolate a variable. Once we have to isolate mathematically. So you saw the definition was isolating, removing from surroundings, kind of like we have here, remove all elements surrounding a variable. This isolating a variable helps us prove the value of that variable, and it also gives us an automatic solution. Meaning when I'm isolating a variable, I might have something like 3m is equal to 27. My goal and my job is to get m alone by itself. I am seeing up here that I have this 3 times m in my equation. I don't want 3 times m, I want just m. I want m alone. And we saw from our proofs yesterday, we're looking for 3 times the number m is equal to 27. Therefore, we know that m has to be 3 times the number m must be 27. Therefore, 27 is 3 times larger than m. M must equal 9 because 9 is 3 times larger, 9 taken 3 times is 27. 27 is 9 times larger than 3. 27 is 3 times larger than 9. It fits into our proof as to why 9 has to be an answer. We have to isolate m in order to get to a solution. So now I know that m equals 9. This is where it tells me that it's an automatic solution because I have my answer. M is equal to 9. It proves the value of the variable because m must equal 9 in order for this entire sentence to be true. And now I'm isolating mathematically. I didn't really show you that, but I'll show you in the next steps as to why we have to isolate mathematically to make sure we get the right answer. But just knowing that these three things help us understand what isolating is and what our goal is. Remove all the surroundings around a variable. Next, we had the golden rule of algebra. This is just a reminder of what that definition was. Whatever you do to one side of the equal sign, you must do the exact same thing to the other. This is where the mathematical isolation stuff comes in. So if I had that answer of 3m equals 27, not the answer, the equation 3m equals 27, I need to isolate mathematically. So I'm looking to do something to get rid of this 3 times m, because I want one singular m by itself. So I'm going to isolate mathematically, and that's going to be using the golden rule of algebra. I'm going to show you in the next slide how to do so, but I'm going to do something here to help me isolate and get m by itself. I have to do the exact same thing to the other side of the equal sign so that everything remains balanced. Because right now, the definition of an equation, 3m is equal to 27, they're the same thing. 3m is equal to 27, they're balanced. If I do something to one side of the equal sign, whatever I do mathematically here, I must do that exact same thing over here. And I'll verify what that means, but just remember that whatever goes on one side of the equal sign when we're isolating has to happen on the other side in order to stay balanced. How do we do that? We use this idea of O.O.I, O-O-I, opposite operations to help us isolate. I'm going to put that original example back up. We had 3m equaling 27. We know what the answer is. We know the answer is 9 because we know 3 times 9 is 27. However, we need to prove it because as we get progressively harder with our algebra, it's not going to be that mental math easy in order to see what that answer is. So if I'm going to prove what m must equal, first I have to isolate. I have to get m by itself. Second, I have to remember that whatever I do to one side of the equal sign to get it isolated, I must do the exact same thing to the other, that golden rule. Now, in order to do those things, I'm going to use O.O.I, opposite operations, to help me isolate. Well, what I'm seeing here first is I'm seeing that 3 times m is equal to 27. In order to get m by itself, I have to eliminate this 3 times the m. So when I'm thinking about that, I'm thinking, okay, multiply. What's the opposite of multiply? It's divide. So now I'm going to divide by 3 here, because when I take 3 divided by 3, that's going to cancel this part out. It's leaving me with 1m. I have that, and that's exactly what I want. I want an isolated m. So I'm canceling out the multiplication of 3 by dividing by 3. I'm helping myself isolate by using opposite operations. So now the golden rule comes in because I have to do that exact same thing to the other side of the equal sign. I have to divide by 3. I divided by 3 over here. Now on the other side of the equal sign, I must divide by 3 in order to remain balanced. That's where I get this answer of 9. Because 27 divided by 3 equals 9. I've now again proved why m must be 9. I used opposite operations to help me isolate away the multiplication of 3. I used the golden rule to use it on the other side of the equal sign to help me prove my isolated answer, m must equal 9. So putting all 3 steps together, for the first one, again, we need to isolate. That's our main goal. Isolate, isolate, isolate. Get the variable by itself. How do I do that? I use my opposite operations. Then when I'm using those opposite operations, think about that golden rule. Whatever happens on one side of the equal sign, everything has to happen on the other side. Keeps everything balanced. So now I have this quick sample here, and I'm going to go step by step, and I'm going to try to switch colors up so I can be showing you each step of what I'm doing, because now I have a pretty complex mathematical equation that I want to solve. So as I go through here, I got to remember my goal. My goal is to isolate. I want m by itself. I want m to equal something. How am I going to do that? Well, I'm going to use opposite operations. As I'm using opposite operations, I need to eliminate everything around m. I need to eliminate this addition of 7 and this multiplication of 4. If I can eliminate those, I'm isolated. I have my answer, but I need to use that golden rule to help me get there. So let's go ahead and do so. So first off, if I need to eliminate those things around m, what I'm first going to start with is those opposite operations. Here, I am seeing that I'm adding 7 to 4 times m. So I'm going to do this in 2 steps. I'm going to subtract 7 because subtraction is the opposite of addition right up here. Subtraction is the opposite of addition. I'm using O.O.I, opposite operations, to help me isolate. Now I'm using my golden rule. I just subtracted 7 from the left side of the equal sign. Now I have to subtract 7 from the right side in order to stay balanced. The golden rule in action. Both sides of the equal sign doing the same thing as I'm getting down to being isolated. Now, as I subtract 7 from both sides, I'm left with something on each. I'm left with 4m left over here because now I subtracted 7 away, really canceled out or helped myself isolate that. 4 times m plus 7 minus 7 is just equal to 4m. And now I'm left with 4m is equal to 24, which is 31 minus 7. I do my process all over again. I'm going to isolate because I still have something surrounding m. I'm going to isolate by using opposite operations, and then I'm going to make sure I use the golden rule to help me get to that isolated answer. So now I have 4 times m is equal to 24. That means 4 times some number equals 24. You probably have the answer mathematically in your head already. We're going to prove it algebraically. So now I'm thinking about, okay, how can I isolate that 4 times away? I'm going to use opposite operations. The opposite of multiplication, which is showing here 4 times m, is division. I'm going to divide by 4. Instead of multiplying by 4 in blue, I'm going to divide by 4 to help cancel out and help isolate. So when I take 4 divided by 4, I get to 1m. And that's what I want. I want an isolated 1m. So now if that's canceled out right there, I'm one step closer to my job of being isolated. However, the golden rule says make sure you do that to the other side as well. If I'm dividing the left side by 4 in order to help myself isolate, I need to divide the right side by 4 to stay balanced. So now I get to my final answer because I know that 24 divided by 4 is equal to 6. M must be 6. If I go back and I figure out, okay, does that work? We'll check that later, but this is how I go through those step-by-step ideas that M must be the value of 6. I isolated everything. I did it through my green opposite operations. Subtracted to cancel out or to isolate away an addition problem, and I divided to isolate away a multiplication problem to help me prove that the isolated answer for that variable m must represent 6. One more final step, and again, I'll go fast through these, but you'll have examples here. You'll have examples from the posting about how to isolate. And again, this is now back to a one-step equation. I just did a two-step equation on that previous problem. You'll see again how we can use those 4 steps in order to get there. So I have 7 plus j is equal to 78. You might know the answer already. That's great if you do. You might know what j is equal to. That's our goal, is to isolate a way for j, figure out what j must be. Again, I want you to prove mathematically to help us set up those skills for when algebra gets really, really tough. So again, want myself isolated. I want j by itself down below. This 7 plus j is stopping me from having j isolated. I need to get rid of it. I need to help myself isolate by having j by itself. How do I do that? Opposite operations. Well, what operation do I see? Addition. Therefore, I'm going to subtract the opposite operation, and I'm going to subtract 7. Because I have 7 plus j, I want to take 7 away. Golden rule says do the same thing, subtract 7 on the other side of the equal sign to stay balanced. So now I know I have j, whatever j is equal to, and I'm adding 7 to j over here, but now I'm subtracting 7 because I want to cancel out all of this stuff to get myself isolated. In order to remain balanced, though, I have to subtract 7 away from 78, and now I can just solve that. 78 minus 7 is 71. J must equal 71. And if I look to see here what's going on with that answer, I can plug it in for j. Does 7 plus 71 equal 78? It does. J must be 71. And through our steps back here, let me get rid of some of this clutter, I showed and I proved mathematically why that has to be. Hopefully these examples help. You have some posted examples from your book, but I want to see these 3 steps: isolate using opposite operations and the golden rule to help prove what our numbers must be for our variables.